Newton's second law of motion. Exactly what it is, we are going to talk about this. According to Newton's second law of motion, the rate of change of momentum. The rate of change of momentum is directly proportional to the force, and the change takes place in the direction of force. Look at this, is very simple to understand. The rate of change of momentum is directly proportional to the force, and the change takes place in the direction of force. First, we have to understand about the momentum. What is it? Momentum is the product of mass and velocity of the body. And that's why if a body is in motion, then the motion may increase or decrease. Its momentum changes according to the change of velocity. Mass remains constant, velocity changes. That's why according to the velocity, its momentum changes. So let's talk about the momentum. Initial momentum. Let's say initial momentum of a body is the product of its mass and initial velocity. mu, m is mass, u is initial velocity. And final momentum. Final momentum of the same body is mb. B is the final velocity, initial velocity, final velocity, initial momentum, final momentum. Okay, now change of momentum. Now change of momentum is final minus initial. That's why final momentum mb minus initial momentum mu gives the change of momentum. Now how long it takes to change from this momentum to this momentum, initial to final, is time taken by that body, and this is denoted by t. That's why if we divide this change of momentum by time taken to gain this much change, then we'll get rate of change of momentum, means change of momentum in unit time. That's why I'm writing now rate of change of momentum. Change of momentum. Rate of change of momentum is mb minus mu upon what? T. Okay, according to this law, the rate of change of momentum is directly proportional to the force. That's why we can write this way: force is directly proportional to the rate of change of momentum, mb minus mu by t. Now you can write here, according to the law, rate of force is directly proportional to rate of change of momentum. Now we can go through simplification. Look at this. So directly proportional, mb minus mu. M can be taken as common, b minus u by t. Now we know that this v minus u by t is acceleration. Acceleration is equal to what? Change of velocity by time taken. That's why we can write f is directly proportional to ma. Now if any two quantities are proportional to each other, then there must be a constant between them. And if we remove this proportional sign with is equal to sign, we have to take that constant in the equation. That's why f is equal to, let's say constant involved in between them is k, then kma. Now the units are selected in such a way that value of k is 1. We can say this sentence: units are selected unit of force, mass and acceleration is selected in such a way that value of k is 1. Or we can say that if f is equal to 1 and m is equal to 1 and a is equal to 1, then k is also equal to 1. What it mean? I want to show this with equation. F is equal to kma. If f is 1 and m is also 1 and a is also 1, then certainly k is equal to 1. If k is equal to 1, then why should we take k in this equation? K can be removed. Either we will write this, or units of force, mass and acceleration are selected in such a way that value of k is equal to 1. Therefore f is equal to ma. Because this is the formula or equation which is derived from this Newton's second law of motion, which can be used to solve the numerical problem. This is law, and this law gives this equation, and so the second law of motion gives the measurement of force. We can say this also. Okay, if you are benefited by this video, and if you think this is helpful to you, then please like it, subscribe it, and if possible, then share it to other also. They will also be benefited by the same. Okay, this much for today.